Hi folks, it's Mr. Defy once again. In this video, I will be showing you two examples using the law of exponents, all the laws 1 through 5. In example 1, we have a bit of a hefty question here. It seems like there's a lot going on, and to be honest, there kind of is. But before you jump right in, it's good to know where everything is located. So I note, first of all, I have a power of 3 that's covering this huge term right here. But that huge term inside the parentheses, that whole thing counts as a base for my power of 3. Now, according to law number 5, which is called power to power, this exponent of 3 is going to multiply. Just like the distributive property, it's going to multiply to the other powers on the inside. Okay? In the denominator, these two u's will combine together using the exponents that you have. So going ahead and putting this into action, what we get is u to the power of 2. It's still there. And it's waiting for a chance to combine with this one, which is still locked inside the parentheses. Okay, so it's going to stay on the sidelines for now. This u to the negative second power will multiply with the power of 3. Then I have a v to the power of negative 2, which will also multiply with the power of 3. Then I move downstairs and I do what I can down there. Now, down here, I have a u with the power of negative 1 and a u with the power of negative 4. According to law number 1 of exponents, when you multiply bases that are the same, you always add the exponents together. Okay? So there I go. This is times v to the second power. Now, going back to the numerator, I have to simplify some more. So I have u to the second power times u to the negative 6th power, that's my new power now, times v to the negative 6th power as well, all over 2u. Now my new power on this will be negative 5. Then I have v to the second power. Okay, moving right along. What I have now is, if I combine these two u's together, what I get is this. Now I have u to the power of 2 minus 6 times v to the power of negative 6. And actually, I'm going to take a shortcut here. Watch what I do. A negative power indicates that the base needs to go to a new place. Now, there are only two ways that a base can move in these cases, up or down. In this case here, my v has a power of negative 6. That negative 6 says that the v needs to move somewhere. The only place it can move to is below. By putting an arrow, I will show my work and indicate to the instructor or just to myself that this v is about to relocate. In the same way, I can take this u with a power of negative 5 and I could move it up. But the reason I'm not going to do that just yet is because I want to see what happens after I combine these two u's over here. Okay? So I'm going to wait to move this until I know what's going on up here. So let's go ahead and continue. So down here I have 2u to the power of negative 5. I have a v to the power of 2 from before, but now it's joined by a v to the power of 6. And the 6 turns positive once you move it from wherever it was before. Now, going back to the numerator, I get u to the power of negative 4. In my denominator, I have 2u to the negative 5th power. And now I have v to the power of 8. If I combine my 2 and 6, I get an 8. Okay? And now, once again, I'm at a situation where I have to decide what I'm going to move. And I have two options. Either I could move this u with a power of negative 5. I can move this up, and I can move this u down. And that would mean that they just switch places with each other. Or I could see which one would give me a positive exponent at the end after I make my move. And it turns out that this, if I were to move this up, then what I would get is the following. I would get u to the power of 5 and u to the power of negative 4. And that 5 minus 4 there will combine to make a power of 1. And that means I don't have to move anymore after that. So it's kind of like a game. You have to use strategy to figure out which one you're going to move and why. Okay, so down here I have a 2. My coefficient is still there. My v with a power of 8. Okay, there's nothing more for me to do down there. And in the numerator, if I combine my 5 and negative 4, I get u to the power of 1, which you don't have to write, by the way. You don't need to write the 1. Some people like doing it because they like to know that there is a visible power. But if you can see the base, it has a power. And if you can see the base, but the power is invisible, that means automatically the power is a 1. And here's my answer. A little bit of work, some steps involved, yes, but this is one way that you can achieve that answer. There are other ways to do this, some shorter with less work, but maybe not as clear, some longer with even more detail, which is never a bad thing. So this is example 1. In example 2, let's take a look over here. In example 2, we have powers of 0. Now, for me, when I see powers of 0, I get happy because a power of 0 indicates that the math gets simple real fast. And anything to the power of 0 automatically becomes a 1. Anything to the power of 0. As long as that 0 covers it, it will turn into a 1. The reasons for that I won't get into in this video, but that is one of the laws of exponents. So if I look at this, I see that I have a power of 0 there. I have a base with a power of 0 there. What I can do right away is I can simply get rid of those because they become 1, which when multiplied to anything still gives you what you had in the first place. So what I do now is I want to clean this up so it's not too confusing. So let's see, what we get left over after that is this. We still have parentheses. My coefficient is 2. Then I have y to the negative 4th. My outer power is 4. Down here, there's really nothing for me to do. Okay. Again, I don't want to move that. I don't want to move this just yet. I could move it up, but I don't want to do that until I see what's going to happen between those two. Okay. Just a strategy. You can do it if you want, but it's really a personal choice. So what I will do now is take this 4 out here, and I'm going to distribute it to the powers inside. Now the y has a power of negative 4. That's pretty clear. The 2, however, doesn't have a clearly marked exponent. But like I just said a little while ago, if you can see a base, it has a power. If the power is invisible, the power is a 1. So if you want, you can write it in there, just so you know what you're multiplying with. And it's also good to do that, by the way, so that you don't end up multiplying the exponent with the base to make an 8. That would be a big mistake. Okay, so what I get from that is the following. I get 2 to the power of 1 times 4, y to the power of negative 4 times 4. Down here, everything I had before is still there. It's waiting for a chance to do something. So back to the top, we have 2 to the power of 4, y to the power of negative 16. Down here, still the same thing. However, there is a difference. The difference is now I can simplify some things. So what I have is I have 4 2's up here. I only have 1 2 down there. So if you think about it in terms of borrowing, 2 times 2 times 2 times 2 versus just a single 2. What you would do is you would divide those and they would eliminate. By crossing them out, you're actually creating a giant 1. And that's what they actually make when you divide 2 by 2, right? What you have left over are 3 2's, or in other words, 2 to the power of 3. So the only way to make a 3 using a 4 and a 1 is by subtracting. So this follows the same principles of borrowing as when you subtract regular numbers. And in fact, that's exactly what we're doing here. We're borrowing. So I'm going to borrow 1 2 from here, so I have no more 2's down there. And I'm going to borrow 1 2 from there, leaving me with only 3 left. Okay, that's my new power on the 2. Now I said with the y's, I wouldn't move this one down here until I first see what's going on up here. A strategy before moving is to see which one, if you were to move it, which one would end up giving you a positive power with the least number of moves. And it turns out if I were to move this y down here, then it would turn positive 16, and when I subtract it with the 2, I get positive 14. Okay? And so that's what I'm going to do. I'm planning ahead. So this is 2 to the power of 3 all over. Remember, there's no coefficient of 2 down there anymore, so it's just x squared, y to the power of negative 2, but it's now joined with y to the power of 16. 2 to the power of 3 is 2 times 2 times 2, which makes an 8. Not 6. Be careful with that. It's 8. So I get 8 over here. Down here I have x squared. Now with these y's, this would be 16 take away 2. So remember, this is one of the laws of exponents. It would be 16 minus 2, or negative 2 plus 16 if you want to do it that way. You could do it that way if you want, going left to right. But either way, you would get y to the power of 14. So that's what I have over here, y to the power of 14. And with that, I'm finished. There's nothing left for me to simplify. I'm done. So I hope these videos helped you out. The trick to doing them is to just be patient. Take your time. Working a little slowly, but taking your time will ensure that you get the answers correct. And it also gives you a chance to just process the different laws of exponents going on at the same time with each other. So stop by, leave a comment, and as always, thanks for taking time to watch. Bye-bye.